Here's the review for the first review video for our next exam, the second exam. And I don't know how far this video will go, but the videos in total will go no farther than we've actually covered, and then I'll make a final one that will cover the last bit, the logarithm part, once I've covered it in class. So we start with question 1, and question 1 is going to have us complete a difference quotient for this function here. And so, as I've said before, remember that wherever you have an x in the function, you want to place a set of parentheses, and inside those parentheses you want to put whatever is in here, whatever the function is asking you to evaluate. And so the first step asks us to find f of x plus h. So I have an x here, so I put parentheses here, and have an x here, and so I have parentheses around that entire expression here. So I didn't actually put a set of parentheses here. I just placed the x plus h inside here because addition is commutative. And so I have x plus h here and x plus h plus 40 here. An alternative to this is to expand this, multiply this out first before you start in on this operation, but this operation is actually a little bit simpler if you attack it this way. So now we have x plus h in parentheses times x plus h plus 40 in parentheses here. And so I make that multiplication by multiplying everything in this expression times everything in this expression. That means that I start with the x and multiply it times x here to get x squared, and I multiply this x times h here to get xh, and then I multiply x times the 40 to get 40x. Next, I multiply the h times everything in these parentheses. H times x is hx, which is the same thing as xh, so that's this term. And then I multiply h times h, which gives me h squared. And then I multiply h times 40, which gives me 40h. Now the only two terms that I can, that are similar terms that I can collect are this xh and this xh. Add those together, you have two of them, you have 2xh. Next, in the second step, we subtract the function from this evaluation that we just made here, f of x plus h. Well, so here's our f of x plus h, and then we subtract the function, which is x squared plus 40x, because it is going to be easier to make the subtraction if I make this expansion first. So I'm subtracting x squared plus 40x from this entire expression. That means I will distribute the negative through to these two terms, and I'll have minus x squared and minus 40x. Well, there's an x squared here and a negative x squared here, so those cancel additively. And I have a positive 40x here and a negative 40x here, so those terms cancel additively. Now, for any of these difference quotients, you will have every term in the function subtract out here. So the function as it was will subtract out and be eliminated. And what is left now is 2xh and 40h and h squared. Then that expression we place over h and reduce. Well, there is an h common to each term in the numerator, and so we factor that h out. It's the greatest common factor of all of these terms. We factor that h out, and it cancels multiplicatively with the denominator, and that leaves us this expression here, 2x plus 40 plus h. Now the next question asks us to determine a revenue function from a price-demand function, and of course, since no other specifics are given for the quantity, and we know that revenue is quantity times price, our price-demand function goes here, and quantity is just x. And so we multiply this x times each of these terms, and we have x times 2000 is 2000x, and x times negative 60 is negative 60x squared. And so that becomes our revenue function. Then we are asked to complete this table by making all of these evaluations. The revenue at 1, x equals to 1, the revenue at x equals to 5, 10, 15, 20, and 25. And when you plug those in to this function here, then you will come up with 1,940 as a revenue for at x equals 1, which is actually 1,000, since these x's are in thousands. And when x is 5, you will have 8,500. And when x is 10, you will have 14,000 for our revenue. And when x is 15, you should have 16,500 as your revenue. And when x is 20, 16,000 is 25. Revenue is 12,500. This is the exact example that we did in class the day that this topic was covered. And at this point, I think I will just call your attention to these numbers near the right margin for each question. These are not extra credit questions. They are just other exercises that are like the one being asked, like the question being asked. So they make good practice. And notice that they are all odd, so the answers will be in the back of the book. And now we'll move on to question 3. Question 3 asks you to use the revenue question that you got in question 2. So I don't normally like to make one question dependent upon the prior one, but this is a pretty simple step, a pretty simple calculation to make, and so I kind of feel safe doing it. And so it asks us to use that revenue function and this cost function to determine a profit function. And then we will find the break-even points and the intervals of profit and loss from that. And then we're asked at what production level is profit maximized and how much is that profit? Well, a profit function comes from revenue minus cost. How much are you taking in minus how much are you spending making the product in question? And so the revenue function is 2000x minus 60x squared, which I've changed the order just because it makes more sense to me to have this profit function in descending order. That is, the x squared term, the highest agreed term, comes first, and then the linear term, the x term, 2000x, comes next. And so we subtract the cost function. Remember, we're subtracting the entire function. And so that entire function is enclosed within parentheses. And so that means we then distribute the negative, distribute the subtraction across each of these two terms. So we are subtracting 4,000 from this function. We are also subtracting 250 from this function. And so that gives us negative 60x squared plus 2000x minus 4000 minus 250x. The 250x is a like term to the 2000x, and so we subtract that 250, and that leaves us with 1750x. So this is our profit function, and to find the break-even points, we want to set that equal to 0. Excuse me. Sorry. And so that's what we do. We set this equal to 0 and solve. So here's my profit function, set equal to 0. And the first thing I want to do is to determine the greatest common factor. And I'm always going to ask to factor out. And so I'm always going to ask, is this coefficient of the x squared term the greatest common factor? Well, it doesn't divide evenly out of 4,000, so I say, well, no, it's not 60. Then what is it? And after I try a couple of values, I find that it's -10. So when I divide -10 out of each of these terms, then that leaves me with 6x squared, because the negative factors out, and this becomes negative 175x, and this becomes positive 400. Now on the exam I will provide, because I know that this might be difficult to factor, I will provide a hint that will say that you should factor using binomials that with one having a 3x in the first term and the other having a 2x in the first term. I will give you that much of a head start on factoring this trinomial. Well, we then, after checking various combinations, find that -80 and -5, or rather 3x minus 80 and 2x minus 5, will give us this trinomial. So those are the two factors. The -10 has no effect on the solution. So we set this 3x minus 80 equal to 0 and this 2x minus 5 equal to 0 and solve, and that gives us 26.67 approximately, and 2.5 approximately, because we add 80 to both sides here and divide both sides by 3, and here we add 5 to both sides and divide both sides by 2. So those are the break-even points. Now the intervals of loss will be from 0 to 2.5, and we include, I have a square bracket here so that we include 0, because if we're not making anything, we're going to be experiencing a loss, because we are at least opening our plant or whatever concern we have going, and we will incur costs just turning the key and opening the door. And we go up to 2.5. I don't include 2.5, and I use the curved parenthesis bracket to indicate that. We don't include 2.5 because we're not losing money at 2.5. We're just breaking even. Not making money, not losing money, just breaking even. And then when we begin to lose again is at this point, because in between we're going to be earning money, we're going to be profiting, and so at 26.67 on to infinity, we would lose money. Of course, we can't make an infinite number of products, but any that we make over this amount will give us a loss. Well, in between is the interval on which we experience profit, and so that's this 2.5 to 26.67. Now, those of you who have graphing calculators can graph this function here and see that it will cross the x-axis at these 2 points.